I can help you with finding information about 10 ways to improve API performance. API performance is the measure of how fast and efficient an API can serve data and functionalities to its clients. API performance can affect the user experience and the business outcomes of the web application that consumes the API. Therefore, it is important to optimize the API performance and follow the best practices that can help achieve high-performance APIs. Based on the web search results, here are 10 ways to improve API performance. Use HTTP/2 protocol. HTTP/2 is a newer version of the HTTP protocol that offers several improvements over HTTP/1.1, such as multiplexing, compression, prioritization, and server push. HTTP/2 can reduce the latency, overhead, and bandwidth of the API requests and responses, and improve the speed and efficiency of the API communication. Pagination and filtering. Pagination and filtering are techniques that can help reduce the amount of data transferred by the API and improve the response time and scalability of the API. Pagination allows the API to return a subset of the data in each response and provide links or parameters for the client to request the next or previous pages. Filtering allows the client to specify the criteria or the fields that they want to receive from the API and exclude the unnecessary or irrelevant data. Apply caching strategies. Caching is a technique that can help improve the API performance by storing the frequently or recently accessed data in a faster and closer location, such as the memory, disk, or browser. Caching can reduce the load on the API server and speed up the delivery of the data to the client. Caching can be implemented at various levels, such as the client side, the server side, or the network level, using various tools and methods, such as HTTP headers, cache servers, or CDNs. Utilize compression techniques. Compression is a technique that can help reduce the size of the API requests and responses and improve the bandwidth and speed of the API communication. Compression can be applied to various types of data, such as text, images, or binary, using various algorithms such as gzip, deflate, or brotli. Compression can be enabled by setting the appropriate HTTP headers, such as accept encoding and content encoding, and using various tools and libraries such as zlib, libdeflate, or zstd. Leverage Connection Keep Alive. Connection Keep Alive is a feature of the HTTP protocol that allows the client and the server to reuse the same TCP connection for multiple requests and responses, instead of opening and closing a new connection for each request and response. Connection Keep Alive can reduce the overhead and latency of the API communication and improve the performance and efficiency of the API. Connection Keep Alive can be enabled by setting the appropriate HTTP headers, such as connection and keep alive, and using various tools and frameworks such as Node.js, Express, or Nginx. Optimize data serialization. Data serialization is the process of converting the data into a format that can be transferred and consumed by the API, such as JSON, XML, or protobuf. Data serialization can affect the API performance by influencing the size, speed, and compatibility of the data. Therefore, it is important to choose the right data format and the right serialization library for the API, based on the data type, the data structure, and the client requirements. Some of the factors to consider when choosing the data format and the serialization library are the readability, the compactness, the schema support, the validation, and the performance. Use rate limiting. Rate limiting is a technique that can help improve the API performance by controlling the number and the frequency of the API requests that a client can make within a certain period of time. Rate limiting can prevent the API from being overloaded or abused by malicious or excessive requests, and ensure the availability and reliability of the API. Rate limiting can be implemented at various levels, such as the client side, the server side, or the network level, using various tools and methods, such as HTTP headers, middleware, or proxies. Monitor and analyze API performance. Monitoring and analyzing API performance is a crucial step to identify and resolve any performance issues or bottlenecks that may affect the API. Monitoring and analyzing API performance can help measure and track various performance metrics, such as response time, throughput, error rate, and availability, and provide insights and feedback on the API performance and behavior. Monitoring and analyzing API performance can be done using various tools and methods, such as logs, dashboards, alerts, or APM solutions. Test and optimize API performance. Testing and optimizing API performance is an essential step to ensure and improve the quality and efficiency of the API. Testing and optimizing API performance can help simulate and evaluate various performance scenarios and conditions, such as load, stress, or spike, and provide recommendations and suggestions on how to optimize the API performance and scalability. Testing and optimizing API performance can be done using various tools and methods, such as load testing, stress testing, or performance tuning. Follow API design best practices. Following API design best practices is a fundamental step to improve the API performance and usability. API design best practices can help create a consistent, intuitive, and RESTful API that can serve data and functionalities efficiently and effectively. Some of the API design best practices are using proper endpoint structure, applying standard HTTP methods and status codes, implementing versioning and authentication, and providing clear and comprehensive documentation. I hope this helps you find the information you are looking for.